All right, on this set of slides, we are going to solve for one triangle with all of these. Remember, with all of these, we want to make sure that we are rounding to the thousandths place or 3 decimals. So my first example that I have here, I have my triangle. This is 10, 90 degrees, and 25. This is x. Now, based upon what I'm given, I'm looking at these angles trying to decide what is the best trig function to go ahead and use without having to do any additional work. So I'm looking at this angle here. This angle is my 25 degrees. So if I'm looking at that particular angle in reference to the fact that this is my 20 angle of 25, what that means is that this side directly over here is the opposite side. And while x in length, x is adjacent, the better name for that is the hypotenuse because it's directly across from the 90-degree angle. So when I'm looking at SOHCAHTOA, what do I have? Well, I have an opposite side and the hypotenuse side. So the trig function that matches best with that will be the sine function. So I say that the sine of 25 degrees is equal to 10 over x. Now, solving the ratio to get x all by itself, I bring x up and cross multiply, and I get x is equal to 10 divided by the sine of 25 degrees. So putting that into your calculator, x is equal to 223 and 6620. I want to round to the third decimal place, so I just go through and chunk that off, and x is 23.662. All right, so this question's a little bit different than we had before because if you look at what we're asking you to do with this question, we are asking you to solve for alpha. So we're asking you to find the angle measurement here. And that's a little bit different. So when you're looking for the angle, there's one extra step. But let's set this up first. So again, this is my angle alpha. If I look at this, this is now in this case, this side is touching this. This is going to be considered the adjacent side. And this, because it's across from the 90-degree angle, is my hypotenuse side. So the trig function that I want to use, remember the acronym is SOHCAHTOA. And because what we have the adjacent side and the hypotenuse, so we need to use the cosine for this. The other two will not work. So I want to go ahead and say that the cosine, and just write the symbol here, the cosine of alpha is equal to 7.52 divided by 8. I'm going to go ahead. So what we want to do here is called find the inverse of this. Now, the notation is a little bit tricky. So what we're talking about with this, here, remember, A is the angle. This is the ratio of the sides of the triangle. When you're given the ratio, you want to take the inverse function of the ratio of the sides of the triangle, and that will equal the angle. Now, it's really important that this is not to be confused with an exponent. That does not mean -1 as an exponent. What we're asking is we want to do the inverse of the trig function. The inverse of the trig function will equal the angle, where the regular trig function is the ratio of the sides. So go ahead, find that in your calculator and put it in, and what you will find is that this is the inverse cosine is going to equal 19.9484. And again, we're still not rounding up. We want 3 decimal places. So that is 19.948 degrees. So to recap, if you have the cosine of an angle, that's going to go ahead and equal the ratio of the sides of the triangle. But if I have the inverse of that function, that inverse is equal to the adjacent over the hypotenuse, because this is a cosine, that will equal the degree of the angle of the triangle. All right, so looking at the next example here, let's talk about what we have in relationships to this angle of 62. The side that is closest, right here, this is the adjacent side. This is the opposite side. And this side over here, which we don't have a value for, is the hypotenuse. So we don't have the hypotenuse this time. So we need to use the tangent function. And that's because the tangent of any angle theta is equal to the opposite side over the adjacent side. Now, we have the angle, so because of this, we know that the tangent of 62 degrees is equal to the opposite, or 14.8, all over z. Getting z by itself, z is equal to 14.8 divided by the tangent of 62 degrees. Plugging this into our calculator, rounding it to 3 decimal places, gives us the fact that we have 7.8692. So with rounding, z is going to be 7.869.